Okay.
Yeah.
Excuse me, are you Amy? Can you help us? It's just nothing's working.
What are we going for?
We're just trying to get something come up on the screen. Nothing's coming up.
Okay.
And then it says check cable.
Well, that's all kinds of fun. Let's try. Let's see if that does it. Sometimes that guy acts a little weird.
Oh.
Okay. And then we're wanting, are you doing a remote conference or are you just in the screen?
Are you recording? Yeah.
Okay,
But not through media site Zoom. He does it through Google, YouTube.
Okay. So we don't need the video conferencing stuff. Okay, let me back out of all this then. So yes, we'll get out of that. And we will send your laptop to both screens.
Thank you. So what did well, you don't want us to know what you did down there.
Don't worry about it. No, one of the components in there overheats sometimes, so I've got to power cycle it. It usually comes back up.
Thank you.
Thank you.
Okay, I didn't.
We're recording, sir.
Okay, I'm just gonna email Spencer and tell him to not come over here, not to waste his time. Wait. Okay. Sorry. Oh.
I was just emailing you. Yeah, something had overheated and they just showed the history started. Yeah, thank you so much. Right.
All right. Here we go. What does your future hold in an attempt to tie together all of these different topics? So these were a few things that have come up that people wanted a little more depth on, and just some projects that I wanted to share with you all. Everything I present in this lecture, I am very much still learning. So if you have questions, I might not have the answer, but we can search for the answer together. So today, I was first going to talk a bit about using R to manage and analyze genetic data. And in talking about that, I'm going to use some project examples that I've worked on that have focused on HIV phylogenetics in North Carolina. We're then going to shift into talking about R packages, specifically how to turn your data and code into easy to use R package for both your benefit as well as the benefit of collaborating with others. And then we're going to delve a little more into collaborating with others, but what I really mean by that is version control, because that can just be such a nightmare when it comes to working with others, or can be, if you have a good system in place, make everything run really smoothly. So that's what we're going to cover today. And at the end of the lecture, we're actually I'm not sure if any of you currently use GitHub or Bitbucket. We'll talk more about those. It's okay if you don't know what those are. But by the end, my goal would be for everyone to have created a free Bitbucket account, which we'll then use during Monday's lecture. Basically, you'll just create a free account online, then you'll be able to run a few lines of code in R, and you will then gain access to data that Alan and Leah will be using in their lecture. So it's just to facilitate sort of you following along with the material on Monday. So just to start off with genetic data, I was wondering if anyone already has experience working with genetic data in R, or sort of knows challenges that you have faced or others have faced working with genetic data not in R. Just wondering what you all thought of, just something you're interested in learning. Okay. Cool. So I guess what I've heard as a common challenge to genetic analyses is that oftentimes you have to use a variety of different programs, softwares, platforms to conduct different pieces of your analysis. And because you're constantly shifting between different programs or software, it then translates into you needing to repeatedly reformat your data, read it into different programs. This can get really tedious and inefficient. Oftentimes we're working with huge, massive data sets, so having to repeatedly reformat it just becomes so tedious and so inefficient. And so R has really entered the scene as this really powerful tool where you can conduct a genetic analysis from start to finish, because you're able to draw on a variety of packages that are available that do different parts of the analysis for you, versus having to reformat your data and shift to a different program or even a different operating system just to get through a full analysis. So basically my second year in the program, I had an RA, and the purpose of that RA was literally just help me like get these HIV phylogenetic analyses out of these like dozen different programs and into R, because there are like so many bottlenecks currently in this process, and we want to be able to do these things much faster and like get these projects to completion. So that was sort of my introduction to using R for genetic data. And I'm most familiar with the packages used in phylogenetics, particularly for looking at HIV sequences. But here I've tried to list some of the common packages I've heard that are good to use for be it phylogenetics or population genetics. For genome-wide association studies, these packages facilitate the analysis of these very large data sets. There are some good tools for initially importing your sequence data into R. And there are many more than just these listed. These links should each go to the CRAN documentation for the package. And then I have a couple other links of sort of more comprehensive lists of packages that might prove useful to you all. So now I'm going to get really specific into just my little corner of analyzing genetic data in R, just to show you some examples. So I focused on HIV, and we know that the global spread of HIV is marked by the virus's high genetic variability and rapid evolution. The virus has very short generation times, high substitution rates, as well as a small genome, which is shown here. And we know that this great genetic variability has an impact on diagnosis, on disease progression and treatment, as well as transmission. And it also really hinders our efforts for vaccine development. So HIV's genetic diversity is really important to study. And so in phylogenetics, we're studying the evolutionary history and relationships among organisms. And what this means for HIV phylogenetics is that we look at differences in genetic sequences of the virus to better understand disease progression, drug resistance, as well as transmission dynamics. So particularly important with HIV, at least the phylogenetics projects I've been involved with, is better understanding who is infecting whom and where transmission is actively occurring to then inform our prevention and control efforts. So now I just have a couple examples of how we used R packages to facilitate these phylogenetic analyses. So the first was to look at pairwise genetic distance. This is a basic measure of genetic diversity, so how different are two sequences. This is a fundamental piece of most genetic analyses. And this had already been computed using different programs other than R, but we just wanted to see how easy would it be to do this in R. We know it's pretty tedious using other programs. And so what analyzing this measure means is if you're looking at the pairwise genetic distance between two sequences from the same person, you're looking at the variability in the evolution of the virus. So how much variability is there over time in the same virus in one person? And then what are the clinical implications of that? Is the virus accumulating mutations that's then resulting in drug resistance? If the two sequences that you're computing pairwise genetic distance for come from two different people, we're then asking a different question. We're asking, are their infections epidemiologically linked? And do they belong to the same transmission cluster? Does anyone have experience with this? Okay, cool. I have very little experience. So to do this, we use the 8 package, which is the package I have the most familiarity with. It's awesome, really great documentation, very easy to use. Basically what we did was we read in this CSV file we had of 15,000 sequences from the HIV genome from 15,000 patients in North Carolina who were HIV positive. And so we just had this like massive Excel spreadsheet that for each person, there was one cell with 1,497 base pairs. And this was all just read in as like 15,000 rows of one character variable. To really be able to manipulate and wrangle and use that data, once we read it in, we basically just use one line of code to change the sequences from the character class to this special R class called DNA bin. This is a really powerful bit level coding scheme for DNA sequences. And I think I think the function is just as.DNA bin. And I think it's typically required that you transform your sequences into this class prior to being able to use all of the powerful functions available for analysis. And then it was as simple as using this dis.dna function, which is included in the 8 package. And that basically computed a matrix of pairwise distances for all of the pairs of sequences that we were interested in. This function is really flexible. There are a lot of specifications you can control. You can change the evolutionary model as well as other specifications for how the distances are calculated. And so then we ultimately, once we had all of these pairwise genetic distance values, used them to define transmission clusters that we found among these 15,000 HIV positive patients in North Carolina. And this pairwise genetic distance measure was used as one of our conditions for defining a transmission cluster, among other things. But an important defining feature of a cluster was that all of the sequences belonging to that cluster had a less than 3.5% genetic distance compared to one another. And actually, I think, a current project that's using some of this code we wrote for pairwise genetic distance, which again is like literally only a few lines, really just is powered by these functions in APE, is looking at when people are newly diagnosed with HIV and then provide the names of their partners for contact tracing. If those partners are found to be HIV positive, we can now look at whether the traced partner sequences actually do cluster with the index participant sequence. So we think that one of these people infected the other person. Is that hypothesis supported by the genetic data? So once you are able to do some analyses to then identify transmission clusters, you typically represent them in what's called a phylogenetic tree. So as I had mentioned earlier, a lot of this analysis had already been done in other programs, not in R. And all of these clusters there were a bunch of clusters that had already been defined. And we basically just had like their output from a program. It was these 40 massive files. Essentially, they weren't PDFs, but they were like as useful as PDFs. With sequences from like almost 2,500 patients that were identified in these like 2,300 transmission clusters. So like, I don't think I can pull one up right now, but like literally imagine like 40 huge PDFs. Like this is just like a tiny part of like one tree on one PDF. And what we want to do is like analyze these and write papers about it and like actually inform prevention and control efforts. But like this is difficult to do anything with. This was really stalling the progress of analyses and papers. Basically what we wanted to do was just easily extract specific clusters as well as these important statistics that define these clusters. So each cluster has this posterior probability value that basically is indicating the statistical support for the existence of this cluster. Each cluster has what's called a median height. So that's corresponding to the hypothesized date that the cluster originated and then the duration of time during which transmission has been ongoing. So like, we also just wanted to know those things and make sure that these trees all consisted of clusters that had sufficient statistical support. And those numbers, they actually don't show up in this image, but they would literally just be like on the branches and on the nodes would show up these numbers that corresponded to the statistics. But like, I mean, originally we were like, I mean, do we just need to like copy these by hand into an Excel file? Like this could take years. So luckily, R to the rescue. So we used APE and we read these 40 tree files into R and we created a data frame with all of the tree data. And it was really exciting and easy to extract the statistics we needed. So this was like the posterior probability among other things. And through that, it was extremely easy to like identify that mostly all of these clusters had sufficient statistical support, so that's great. There were a really small number of them, I think about 20, that had probability values that were lower than sort of what's the acceptable threshold for statistical support of the cluster. So we then eliminated those from our prior analyses. So then we could actually move on with our analyses and one, be able to do them, and then two, also know that we were analyzing clusters that like were indeed statistically supported as such. So those are just two examples of my limited experience working with genetic data. I'm gonna move on to package development unless there are any questions here. Does anyone have any genetic epi projects in mind they want to use R for?
So I was hoping to look at just like 7 different SNPs.
Mm-hmm.
Do you think using these packages would be helpful, or would it just be better to just use standard R methods, so few snips.
I'm not sure. I don't have any experience with like specifically looking at like particular SNPs. I feel like Mike, do you know like what does like Antoine do? Is like usually just the question I ask. Like, have you talked to any other EPI students who are?
I mean, Antoine, I talked a little about his genetic work.
Yeah. Like, do they just try to do it all in R?
I wouldn't be surprised. I don't know for sure.
Yeah. But we can definitely like connect you with people who are doing similar studies. I don't think what I've done is similar enough for me to be able to give you a good answer, but hopefully you'll be able to use R. Cool. Anyone else? All right, packages. So, what are packages? You've been using them a lot, but they aren't just something that you can install and use. You can also create your own packages, and they're really useful. You can think of a package as sort of this fundamental unit of reproducible R code. There is this book that's you can order a hard copy of or just read for free online by Hadley. It's very helpful, and it sort of goes through the whole process of package development and best practices. So what a package consists of, you're most familiar with those functions, right? Like you get a package to then use one of its functions. So they consist of these reusable R functions that serve a specific purpose. A package also has documentation describing how to use those functions. Like if you type in your console question mark, whatever the function is from a package, like a little help screen pops up and gives you, some guidance on the arguments and specifications. Some packages also contain sample data. Mike, I was trying to remember like from Tidyverse and other packages we've used, if we've used any of like the built-in data.
We looked at Iris briefly.
Iris, Star Wars, maybe. Yeah. So oftentimes, like I was just talking about the genetic epi packages, like the 8 package has this like example data set called Woodmouse, where you can like practice using some of the functions before, like if you aren't feeling quite confident enough to use it on your own data. And then there's typically documentation sort of showing you what you should get if you run these functions on their data. So it's all just really helpful.
If you type data, the function data into R, it'll spit out all of the data sets that are in base R. And at the bottom gives you a function, data package equals whatever, and it'll tell you all the data sets in that package.
Awesome.
So data parentheses.
Awesome. Yeah, that's really helpful. So packages have, these different pieces, and by turning your code into a package, it benefits both you and others. It can help you to efficiently rerun prior analyses or use your previously developed functions. I have so many times had the experience of I'm trying to code something and I know I could do this in the past and I can't remember how to do it, and I'm like digging through old scripts, but like if I just created a package that like saved that function, I could just load the package, use the function, and like save a ton of time. This is still not something I'm good at doing, but I'm trying to get better at it. And then in addition to helping you, creating an R package helps you to share your code with others. You can just, like, someone can just download your package and use your functions or look at your data, and it's such an easy way to collaborate. And obviously, like all of the packages that are available through CRAN, we all benefit from those. People are sharing their code with us. So how do you do this? It's actually pretty simple. These screenshots and instructions I've just pulled from the website for Hadley's R packages book. To create a package, you actually have to first create what's called an R project. Have we talked about projects in R? So an R project helps you to just better organize your work. And a project contains your code, which is sort of the centerpiece of what you're doing in R. So the scripts you're writing, a project could contain one or more scripts. A project also has any documentation for that code, like a README file. And then a project can also contain the data that you're using those scripts for. So, Mike, is there anything you would add to that? I'm not sure if I'm leaving anything out in terms of describing what a project is.
No, we demoed briefly some Markdown, but Markdown is how you write all the documentation also. So
Yeah.
a lot of these pieces come together around packages.
Yeah, yeah, exactly. So to create a package, or to create a project, which then allows you to create a package, you go to File and New Project. You then select a directory. So this is just the location on your computer where you want this project and all of its requisite files to be stored. So, you know, some subfolder. You can then select that you're creating an R package. All of these are just point and click screens, but you can also code this. But it's pretty simple, so I usually just go through the dialog boxes. So you can give your package a fun name and then just create the project. And so the project has the R scripts, the data, the documentation, all of the elements of what could ultimately become a package. So the R project file will show up in whatever directory location you've chosen. You can just double click it. It'll open in RStudio. You can start working on what could become a package. So you're likely writing some R scripts, doing an analysis, writing some functions that you want to be able to use in the future. You're perhaps developing some documentation. This could be, you know, documentation for others to show them how these functions work. I often need documentation just for myself to like remind myself how I did things, why I did things. And so those can be README files, they can be vignettes. I think in R, a vignette is considered sort of like a long worked example that oftentimes is using data that's provided in a package to then showcase the functions that the package provides. And so once you have this R project that contains, you know, some or all of these things, you can then create it into a package. And when you're working in, when you've opened a project, you will suddenly have a build tab next to the environment and history on like the upper right of your screen. And you just use that tab to then compile all of these project files into a package. And the goal would be that you can then open R and just type library my package, and suddenly you have easy access to all of your functions, your data, whatever it may be. If you're giving someone else your package, they install it, do that, have access to everything you've created. So it's really, I think Hadley goes through this like very clearly and as simple as possible. And I think it's something I need to get a lot better at doing and have no reason not to be better at it. So now just to show a couple of examples. This is just getting like going to a lot of different topics. So I was working with Alan Brookhart this summer, and basically he is creating an R package that I'll get to in a second. But to help orient me to how to create a package and like how to effectively help him to create his package, we decided to create just like a fun test package called SharkR, and I named it. I was really proud of it. This package, like we I'm not sure how useful this would be for you all, but basically it just enables access to data from a multi-year longline sharks sampling survey. It was conducted from 1972 to 2011 by Dr. Schwartz, who was here at the UNC Institute of Marine Sciences. I've included a couple links in the upper right corner if you want some more information on the study, and I believe Alan was involved in this a while back. Over all of these years, a lot of data was collected on shark abundances, species, and sizes. And ultimately, there's this data set of almost 8,000 shark observations with variables on various details of the shark capture and like weather conditions and tide conditions. So we created this Shark R package that just has the data, and then also just created a little vignette sort of going through some basic analyses, looking at here are the different species of sharks that were caught off the coast of North Carolina. This is like the one and only time I've created a pie chart. Will only be the only time. Also looked at like the number of sharks that were sampled each year really started to decrease. I'm not sure if that's like a artifact of the sampling or if the shark population is diminishing. I can't comment on any of the causal relations here. We also looked at the average shark length for some of the most common shark species. So this was all just kind of for fun, like let's figure out how to make an R package. This package isn't on CRAN, so you can't actually like do install packages, Shark R. But what I'm gonna get to in a second is these packages are available on a Bitbucket repository. So you can download from that Bitbucket repository, which we will be getting to at the last part of the lecture. So that was all to inform package development for, we were also working on a package to enable access to data from the WISE, the Women's Interagency HIV study. This is an ongoing observational cohort with regular visits taking place at 10 sites in the US, including UNC. And Alan and Leah will actually be using data from this study on Monday. And so we will use this package, and I'll make sure you all have access to it today through Bitbucket. And hopefully that'll also highlight for you how sort of packaging these things up, literally, then makes it easier for us all to be, you know, working on an analysis together, sharing data. And so creating these packages with data was then sort of leading up to this IPW risk package that Alan is working on. The goal is to provide very easy to use tools for doing advanced causal inference analyses. So using IP weighted estimators, these things that seem really scary, especially in 722, but his goal is to have an R package that makes them just very usable and very clear and transparent to epi students, among others. So I think that'll be really exciting when it's done. Okay, so any questions about package development? And then we can move on to like, what does Bitbucket mean and how do I access these things? Okay.
I have a question.
Yes.
How long did it take you in reading advanced R to like wrap up a package? And you know, there's like you could install dev tools and then like you can just like suck down any package that you find anywhere. It doesn't have to be on CRAN. Like was that like first day and spend a couple hours.
Like a couple days, yeah. It's pretty simple, I think. Or maybe I'm just doing something wrong, but it's actually a very straightforward process. And I think there's definitely a lot of encouragement for people to, create more packages and use packages to help organize your code and ultimately do better analyses. So I think they try to make the process as simple and clear as possible.
Were you working on code with Alan or others also? Like, were you both iterating on the same package using the Git or Bitbucket or whatever?
Yeah. And so that is a perfect transition into working using Git. But so yeah, I said this was team collaboration, but what I really mean is version control. So version control is always important, but it's really important when you're working on code together. So I'm sure everyone here has some experience with version control software. We all use like Dropbox and Google Drive and all of that. But like, how would you effectively use those things if you were working on like a pretty long and complicated R script together? Like, do you see where there could be like a lot of room for like mistakes to be made and like work to be lost? Has anyone had this experience? Yeah.
Even just me and previous versions of myself.
Yes, exactly. So like we need something more powerful. Like these like version control software that we use just for like Word documents, like that's just not sufficient when we're writing code with other people or just with yourself. So we want to use some powerful version control software that is keeping a record of the entire history of a file, and that file could be your R script, and that allows you to then like resurrect the file, like prior versions of it, and inspect it throughout its lifetime. You also want to like put like bookmarks or tags in it, like so you can return to like prior versions of it very easily if you're sort of trying out something and you aren't sure it's going to work and you want to be able to revert back to an original form. Version control software also obviously facilitates collaboration with others, and it really increases the transparency of what each group member is doing to the code, to the project. As I mentioned, it enables this sort of experimentation where you can sort of go off in the woods and see what happens and know that like your working version of your code is safe and you can always get back to it. You can kind of think of this as like the lab notebook of the digital world. And that is all discussed at the link I've provided here. We'll give a little more of an intro. So Git is a very powerful implementation of version control. I would say like Excel is to R as like Google Drive is to Git, maybe is the analogy. I don't know. Is that, it's okay if anyone disagrees. But Git is, as I said, very powerful version control software. It very easily tracks changes to your code. It facilitates sharing those changes with others. You can very seamlessly integrate your contributions to a file, to an R script that others are working on as well. It stores the entire history of your project or the entire history of your R script, both locally on your computer as well as on a public repository. And that repository would be a website like GitHub or Bitbucket. RStudio is awesome to use with Git because it provides shortcuts to common Git commands. And ultimately, it makes sharing your package so easy. So I have a little graphic up here. I don't think I'm qualified to get into the weeds of Git commands with you all, but on the next slide, I have a lot of really helpful resources. In order to use Git, you will have to learn some basic commands for essentially how to save what you're working on, how to share it with others, how to return to prior versions of what you've been working on, how to flag different pieces of your project. But you can sort of think about, like, you're working on your project in your working directory, in your local version. You're making changes, you're making additions, deleting things. You can then choose the changes that you make to then share publicly with the public version of your code, which is on GitHub or Bitbucket. So you can then stage those changes, and then you can commit to them. You can push them up to the public version and then allow others to access and see those changes and further collaborate. So there is so much I'm not covering. And so I think these links are really helpful for sort of explaining the Git workflow and those basic commands that you can, I mean, you really don't have to learn very much about like the Git command syntax if you're just using it from RStudio, because RStudio makes it so easy to use. But I'm happy to chat more, answer any questions if things are unclear. But basically, I wanted to end today with going to Bitbucket, which is a free public repository to use with Git. Unless you already have a Bitbucket account, please sign up for a free one. You can just use your UNC email or Gmail or whatever you want. And then basically, once you have a Bitbucket account, on Monday, you'll run this code, or Alan and Leah, depending on what packages they want you to access, might change this a bit. But basically, by installing and loading the package dev tools on in your RStudio, you can then run this install Bitbucket function that will then download the packages that are available on Alan's Bitbucket repository. It's called Novasci. Under like authenticated user or authorized user, you'll replace your email at yourdomain.com with the email address you used to sign up for the account. And then a little pop-up will, when you run this, you'll get a pop-up for you to enter your Bitbucket password. Then once you do that, you'll download, like, the packages will be automatically downloaded from the Bitbucket repository, and you'll be able to load them just with library and then the name of the package. And I think they'll want us to use the WISE package, but this might change a bit on Monday. But that's the basic idea.
And why do we need, like, it seems like I could install it without authentication. What do you know, like, if we're planning on committing changes to it?
Yeah, actually, that's a really good point. I always have to put my user and password because I'm committing changes to it. But if you're just using it, you might be able to just skip the user password.
I think I just did. So.
Okay.
So I think you just need DevTools install Bitbucket, that first thing in quotes, and then cut right to library WIHS 2009. If you haven't installed DevTools, you need to do that.
Yeah.
But
so yeah, I'll change that. Don't worry about the other stuff. But yeah, like if you were working on a package with someone and you were downloading their version of it from Bitbucket, you could then, if you're signed in to Bitbucket and get it in RStudio, you can then make changes, additions to the code, and then through RStudio, it's called, the Git language for it is you would commit those changes and then you would push them back up to the public repository. Whoever you're working with could then pull them down, see what you did, and continue working. So it's a really smart system for collaborating with the others and version control, avoiding the version control nightmare.
super cool.
So would they be able to use the DevTools installed Bitbucket if they didn't have a Bitbucket account?
I just did.
And you don't have a Bitbucket. Okay. So maybe you don't need a Bitbucket account. Alan and Leah had told me to have everyone create one, but it seems like we could eliminate that step.
I don't know. I mean, if they're planning on having a submit changes, but in the same way, like you can use this to install off any location on the internet. You know, install
Yeah.
CRAN, install Git, install GitHub. I do all the time.
Yeah. A lot of
so-
packages are hosted on GitHub. They are not officially part of CRAN.
Yeah, and so that's why, like, if you're following, particularly, for me, like, if I'm doing like some weird analysis that involves a visualization that's not on CRAN, then I might follow the development of a package before it gets to CRAN. I'm just like googling around and I find somebody built a tree map thing that's not on CRAN yet or not part of ggplot yet, but it's on GitHub. So you can use that same function, just install GitHub instead of Bitbucket, and grab that person's personalized package off the internet and do your work with it. So pretty slick.
Yeah. Do you have any other thoughts to add about Git in general?
I'm curious practically for you, since like I haven't made the transition to using Git as much as I should, and I think everybody I know says that. So what do you do now really in version control? Like, do you version control your own work? I'm so often like creating some too massive script for an analysis. Like I just have like 1,000 lines of code just hanging around, and I should probably put it up on Git. But
yeah,
how are you transitioning to doing this practically?
Yeah, I mean, I think you could think about. I was gonna try to draw something, but it wouldn't illustrate what I wanted it to. So I think with like dealing with like really huge, cumbersome R scripts, like if you could identify sort of what the core of that script is, and then in using Git, you would make that file be on your master branch, and then you could branch off of it and like add on to the code with like different pieces or different functionalities that like, I mean, I guess it just depends what the purpose is, but I think it does help you just be more mindful about how you're organizing your work and like sort of what pieces you need for what projects. Because yeah, it sort of facilitates you just thinking like sequentially, like this is the main script I need. Here's some other things I'm trying to do, but this doesn't all have to be stored in just one long script.
Yeah. I mean, like I write, I use a lot of functions that I define, as I go. But I'm curious, like, do you write a few hundred lines of code and you're like, you know what, I really need to move this over to a package?
Yeah.
Start to get disorganized or whatever.
Yeah. Yeah. No, I mean, that's a call I still need to make. I have mostly I've been working on getting better about using Git when I'm working with other people, but it would be hugely beneficial if I created packages, put them up as a repository, used Git, like just on things I'm working on myself. And I think when things start to get really long and include a lot of user-defined functions, that's a sign that like this should, like we should have a better system for this. Like we should make this a package. I should start using version control.
I mean, I'll add practically. I'm thinking about when Libby and I were out in Seattle, their whole health department uses Git.
Cool.
So it's a way that they can be documenting their work. Also, I mean, at least the programmers, the both R and I think the SAS programmers are also trying to use Git, but for documenting and reviewing code, for submitting changes, for collaborating in practice in epidemiology in the field. People are doing this, and so I feel like it's sort of on my list.
That's awesome.
It's not just academics, like certainly like this is, there's a Microsoft GitHub, there's Microsoft R packages that they're developing, using R. So it's certainly in the programming field, but also in epi practice. It's going this way. And we're having the same conversations at the state health department in North Carolina around version control, because everybody's got their own SAS scripts hanging around, and that's not like a long-term strategy.
Yeah, and I probably didn't state this clearly, but essentially anytime you're committing changes to a script you're working on, you also must include some sort of annotation describing what you just did. And just like having like those running notes is so helpful for understanding, okay, wait, how did I get here? How do I go back? Or if you're like starting a new analysis and want to remember how you did it the last time, like it truly is like a lab notebook for what you're programming on your computer.
One last thought. So, we've talked about, in terms of the course structure, we've talked about having a follow-up course that probably won't happen this spring, but I think long-term, there's this idea of spending more time on maps, having group projects that use CRAN or Git, walking people through the sort of next level of R, package development, wrapping up a project in package. These are the kinds of things where, as we do, the last day class is going to be like a feedback class. So it would be useful to be thinking about the kinds of work that you want in a follow-up R class, as well as changes to this class, for the future for other people. But it seems like it's becoming like a two-parter.
Yeah. Yeah, it would be cool if the next level of the class used Git for everything.
Yeah.
I will.
Yeah.
Yeah. No, definitely. Over the summer, I took like a 2-week. It was like an infectious disease modeling course in South Africa, and everyone there, it was like students from all over the world, like all totally different backgrounds, most with zero Git experience, had never even heard of Git. We were all required to use it for that week for accessing code and data, for doing group projects together. And like the first couple days were miserable because people were just like, what is this? I don't use it. But then like when you're forced to confront it and use it, by the end, like everyone was totally fine, and it made things so much easier. So even in like that short 2-week period of time, just like forcing yourself to dive into it, like you'll pick it up really quickly and it'll serve you extremely well in the future. So yeah, so that's all for today. Happy to take any other questions. Otherwise, we'll see you all next week.
Well, there are NLP packages that do that.
Okay. I'll do that.